Hello, everyone. Welcome back. I am Sergio Lennox, and this is Algebra 51, Solving the Mysteries of Algebra. And today we're going to talk about writing equations of lines. And before you before we start writing any equations for lines, there's a few vocabulary terms that, the reason why I like to tell these right up in the start is so as I start using these terms, you'll be able to know what I'm talking about. The first one we'll talk about is direct variation. Now, direct variation is two variables, x and y, show a direct variation when y equals kx and k is a non-zero constant. Now, you're probably saying, huh? What that says is this, when you talk about direct variation, this number here is this number here has a direct variation on y. Let's do that again. This number here has a direct variation on y, provided that this letter is non-zero. Now, if this were 0, it's going to be y equals 0 all over the place. It's going to be the y-axis, okay? But this number here will make this a linear equation where the line could draw like this, and the line could draw like that. And the point is, it has this right here directly affects this, which directly affects that. It's a direct variation. So for example, if x equals 1 and this whole thing is 2x, let's say k equals 2. If I put x equal 1, it's going to have an effect on y, and it's going to make it equal 2. So so k is a non-zero constant. Now, after I wrote this, I just thought, I think I'm repeating myself. But that's okay. It's okay to repeat yourself. If you repeat yourself, it might increase your chances of memorizing it. But the non-zero constant in a direct variation equation is k. This is the non-zero constant here. This is the thing this is a direct variation where y equals x. It just makes it a straight line. Doesn't do anything crazy. It just draws a line like that. And this k is a direct it's the non-zero constant in this direct variation. Okay, that's all that is. Very easy. Now it sounds very hard and complicated the way I read it, because that's kind of like the official definition. But the official definition is more confusing than the fact, hey, all this is saying that this right here affects y when it doesn't equal, as long as it doesn't equal 0, whatever x is, it's going to be a direct variation in y. That's all it means. Direct variation means it happens exactly the same every time. It'll draw a straight line. Direct variation. Boom. Okay? Any questions? Sorry, that was my drink. All right, so now we're moving on to slope-intercept form. Now, everybody should already know this. If you've been watching my other videos, you should know this because I've already talked about it. But I'm going to talk about it again. Y equals mxb is your slope-intercept form. And if you remember when you drew a line, the slope-intercept form would be this right here. This would be b, because it would be hitting the x-axis. Okay, so this is your slope-intercept form. Point-slope form. This, something very interesting about this. Y minus y sub 1 equals m times x minus x of 1. Now watch this. This is fun to do. Let's use blue. If I were to take this entire thing here, now these are two factors, m and x minus x of 1. If I were to divide the entire thing by x minus x of 1 and do the same thing over here, x of 1, that was a terrible, terrible x. Now, this right here, this cancels out, right? And this becomes m on this side. And on this side, it's y sub y sub 1 over x minus x of 1. And that is the same as rise over run. Remember that? We talked about that on the last time we were talking. Rise over run. That's our slope. And that's the exact equation. This one right here, this y minus y sub 1. That is the exact equation right here. So the point slope form, let's write it again. Point slope form is y minus y sub 1 equals m times x minus x of 1. And that's all we got to remember. And I'm putting that there for a reason. I want to be able to have it there whenever I use it for something else. Now, the first thing we're going to do now is we're going to write an equation of the line. Now, we're going to be given the slope, which is m, and the y-intercept, which is b. If you got that, you've got it. You've got everything. You don't need anything else. You got your equation. You'll write y equals mx plus b. Awesome. Now, what do we know about m? We know that m, we don't know it yet, but I'm going to tell you, m equals negative 3/4, and b equals 2. Now, if we know that, if we know that b equals 2, and m equals 3/4, we got enough to write an equation. Let's y equals negative, what's wrong with this thing? Negative 3/4 x plus 2. There's your equation. Can't get any easier than that, right? If they ever tell you, if you know the slope and you know the y-intercept, you know the equation. Bam! Like that? Great. Good job. Now, the next thing we're going to talk about, and that was example number 1, and so we're going to go to example number 2. Okay, on example number 2, write an equation of a line that, now this is a very good one. Write an equation. We're going to have a point, and we'll call this point P1. We'll just call it point P. We can just call it point P because there's only one. And it passes through a point of 1 and 2. All right, so we got some variables there. And it has a slope of 2. So m equals 2. There we go. If we know that m equals, now you know that a point passes through a point of 1 and 2. You know that the slope is 2. You can turn around and take this problem and you can say, all right, let's see, I got this point passing through this point at point 1 and 2, and I got this. So let's write out what we know. I know that this is x of 1. We'll call this point 1, so this is going to be x of 1, and this will be y sub 1. So we have a really nice equation right here. Where did I put it? There it is. Let me see if I can bold it up for you and change the style of it. We'll make it a little bit bigger. And let's see, I'll duplicate it. Let's bring it on down here. Let's bring it on down to where we're working. So now we got this problem here. Lo and behold, we got a problem we can work with. Let's do it in a darker blue. All right, so now we know we got y sub 1. We have y sub 1 here. We got x of 1 here. We got m here. So let's write them all out. Okay, we're going to start with y minus y sub 1. What was y sub 1? Y sub 1 was 2. It's right there. Next is, we know the slope. The slope is 2 times x minus x of 1, which is what? 1. So now we have enough to figure out what we got. Y minus 2. We just start doing out good old manipulative algebra, right? 2 times x is 2x minus 1. 2 times 2 is minus 2. Now we're going to add 2 to this side and add 2 to that side, and we're going to get y equals 2x. Bam! Isn't that nice? Y equals 2x. Guess what? That looks like that old thing. That's a direct variation, right? Y equals kx. In this case, k equals 2. Right? So now you have the slope of 10. Y equals y equals 2x. That's it. All right, and that's slope-intercept form. We can actually take this and get it that way so it's not confusing. That's slope-intercept form. So let me ask you a question. If this right here is in slope-intercept form, and slope-intercept form is y equals mx plus b, what's the b? Anybody know? It's 0. Plus 0. We just don't write plus 0 because we look stupid. Just kidding. But the point is, 2x plus 0, b is 0. That's what it is. Because just because we didn't write it doesn't mean it doesn't exist. It just happens to be 0, so we don't bother to write it. Just like we don't write 1x. We don't bother with that. We just write x. All right. So now that in itself that's a pretty cool problem, right? All right, let's go to example number 3.
Okay, and now we're going to try example number 3. Write equations of a perpendicular and parallel lines. We're given a point, which is 20.1, and we want to write an equation where the line is perpendicular to this equation, and then we want to write another one that's parallel to this equation. That's how we want to do this. Now, we must ask ourselves, what is it that makes a line parallel and perpendicular? Well, if it's parallel, that means they have the same angle. If you have a line here drawn right here, you have another line drawn, and it might not be in the same area, but it's got the same angle. It's got the same angle for the line. It equals. But if it's perpendicular, we'll have, let's say you have a line here and it's perpendicular and you want to draw straight up, it's got what you would say, it would be a 1 over a negative whatever the slope is of that line. That's how that works. They used to call it flip and negate. Flip and negate. Flip and negate. Because what you're doing is you are flipping a number, turning it into a reciprocal by flipping it. Instead of m, you have 1 over m, and then you would negate it. You would make it a negative number. So it's a negative 1 over. It's negative 1 over the slope. Anyway, that's how that's done. Now let's go ahead and give a shot at one. So we're going to look at point 2, and we know that first thing you want to do is you want to say, let's start with let's do a different color. Let's do blue this time. And what you want to do is you want to say that first of all, we know that the slope, we know what the slope is. But we want to, for a perpendicular one, you want to say M2. I'm going to call it M2 because you're going to use M1 to discuss this particular slope right here. So that's a negative 1 over m1. So the m2 is going to have, you got a point here. You can use the equation with the points, and you have a point 1, so you have a x1 here and a y1 here. That's an x, by the way. And now you want to write the equation. You want to say y minus y sub 1 equals m2 times x minus x of 1. That's how you do it. And then you plug it all in. Now the first thing you do is say y. Let's slide this up a little bit. We know that the point is 2 and 0, so the y sub 1 is 0, so it's y minus 0 equals, and we know that the slope is negative, would equal, let's come on, what would this equal? Negative 1 over 2. That would be m2. That's how you find that slope. So m2 would be negative 1 over 2 times x minus, and you got your x of 1, which is a 2 here, and you multiply it out. Now you want to continue to clean it up. This is pretty easy. This is already, right here, this is easy because that's already been established that is 0. That's a 0, so that goes to 0. So this is y equals, and now we're looking at the 1/2, and we're doing the distributive property of all this, and this becomes negative 1/2 x, and a negative 1/2 times a negative 2 is a plus 1, and that becomes, and this is the perpendicular line of that, of this line here. That's the perpendicular line of that. Now, what about one that's parallel? Now, the one that's parallel is very easy. They have the same slope. So you want to look at, so you know m equals 2. You have the point, which is, and I'm going to rewrite it here, point 1, which is 2 and 0. And there's your x1, and there's your y1. And so now you got to do is plug all this stuff back in. You say, okay, this is going to be y sub 1, y minus y sub 1 equals m times x minus x of 1. And now you're going to take this particular thing, you're going to plug everything in. That's a 0, so y minus 0 equals, and the slope is 2 times x minus 2. And now you're going to say y equals 2 times x is 2x. 2 times minus 2 is minus 4. So this right here is the parallel line that passes through this point, and this right here is the perpendicular line that passes through that point. And those are your answers. And that's all there is to that. Okay, in example 4, we talk about writing an equation giving 2 points. Now, sometimes you're not given the slope. You're just given 2 points that could be anywhere on that graph. So it's going to be a little bit trickier, but it's not that much trickier. So best thing to do is to go ahead and write your equation down. You want to start with blue here. I want to say y minus y sub 1 equals m times x minus x of 1. Now, I'm going to turn around and I'm going to rewrite. I got a different, what we have to do is we have to find the slope. Then we know the slope equals y sub 2 minus y sub 1, which is rise over run. Remember, that's the rise. And then we got x of 2 minus x of 1, which is the run. Now, these two right here, these two equations here, they're very similar, very similar. But in this case, we're going to use the y sub 2 of 0.2 and the y sub 1 of 0.1, and vice versa. And also for x2, we're going to use 0.2, and for x1, we're going to use the x in 0.1. So that'll give us the slope. So that will put us, and then we can put anything we want. So let's go with slope. Now the slope is going to be m equals, now we'll take y sub 2, which is this right here is this is your x of 1, y sub 1, x sub 2, y sub 2. This is a good way to do it. And plug everything in. Y sub 2 is minus 2. Whoops. Minus 2 minus, and I like to put these in parentheses because it keeps it from getting confusing. Minus y sub 1, which is 3. And then we take over x of 2, which is 3, minus x of 1, which is negative 1. And if we clean this up, this becomes negative 2 minus 3, and this becomes 3 plus 1. And that equals, the slope would be, what would that be? That would be negative 5 over plus 4. And that is your slope for this equation. Now, here's the cool thing about this. You can use any of these to make it work. Any of them, because they work. They all work. You can take, now you take the y sub y minus y sub 1, and you might as well use y sub 1 here. But you can use y sub 2, believe it or not, but it doesn't matter. Equals the slope, which is negative, we'll just write the slope, we'll write the program out. My x minus x of 1. Now we just go y minus the y sub 1, which is 3, equals x, this is be negative 5 over 4, because that's what the slope is, times x minus x of 1, which is minus 1. And this will be, and this becomes y minus 3. We can't do anything because we got to multiply this. We got to multiply this out first. So this becomes negative 5 over 4x. And this becomes 5 over 4. This is a plus 1. Plus 1. But it becomes a minus 5 over 4. Let me rewrite that. Minus 5 over 4. Now, in order for us to add, now this is tough. This is tough. It's just fractions, though. Fractions aren't hard, but most people find them difficult. Now you have to realize that what equals 12? What times 4 equals 3? That's probably how I should have worded that. Y minus 12 over 4. I can only add it if they have the same denominator. Now this equals 3, or minus 3 in this case, because 12 over 4 is 3. So now we can rewrite this again, where that's x minus 5 over 4. And now to straighten it out, we're going to add 12 over 4 on both sides. Add 12 over 4. Now 12 minus 5, because that's a negative 5, that becomes y. This right here is gone, so that becomes y equals This becomes negative 5 over 4x, and 12 minus 5 is 7, so that becomes plus 7 over 4. And this is your answer right here. And that's how you write an equation. A little bit lengthy, took a lot, but I did a lot of steps because I wanted to be very careful not to make any mistakes. But some people can probably do this with fewer steps, but that's okay. As long as you don't make a mistake, you're fine. And that's how you do it.